Hello everybody, and once again welcome to Pankaj's Echelon Tutorials, and this is the continuation of my video on factorization for the class 7 ICSE students. Okay, so this is for ICSE 7th grade students, and the topic is, of course, subject is mathematics, and the topic is uh, factorization. All right. Now, in the last video, I had discussed how to factorize using the grouping method. Okay, and before ending that video, that was perhaps the second video. This is the third one on factorization, and there I had mentioned about difference of two squares. This is the next method that we are going to discuss today, right now. So this is the method on which the factorization can be done, and the name is difference of two squares. Okay, now what is this difference of two squares? Basically, it's an identity which we will be using. So you all know that a square minus a b square can always be written as a plus b times a minus b, right? This itself is a tells you that this is a kind of a factorization. Why not? This is a square minus b square, two terms separated by a minus. So it's a expression in difference or addition. Okay. And it has been converted into a product of the two terms, a plus b times a minus b. Of course, this is factorization. So we are going to use this method for factorization now onwards. So suppose you want to factorize x square minus a 16. All you have to do is let this be x square, and this 16 you can write it as 4 square. Now this tells me that this is of the form a square minus b square. Okay, and it can be written in this form. Okay, so this can be written as x plus 4 times x minus 4. Done, the factorization is over. Okay, so this expression, which was in a sum difference form, has been right now converted into a product form. So factorization is done. So is that simple. All you have to do is you should try to bring the expression in the form of a square minus b square. Apply this identity and just write down the factors. Okay. So that was regarding this method. Now let us do some examples for practice, and I'll take some tougher ones right from the beginning. So example number one. Let us factorize 25 upon 36 n square minus a 144. Now this looks very tricky, very difficult. Okay, but not. Let us see what we can do. This 25 can be written as 5 square. 36 can be written as 6 square. N square, I'm going to keep it as it is. And this minus 144, can I write it as a 12 square? Of course I can. Now, this squares, that is 5 upon 6 square, I'm going to place it on the top of the bracket, okay, which I can always do if at all you know properly the laws of indices and all that. Okay, so this 2 can be brought over here. Now, this is of the form something square minus something square, which we wanted. So, if we want to now factorize it, this is of the form a square minus b square, isn't it? So if you want to factorize this, you have to do is a plus b times a minus b. That's it. So here it will be 5 upon 6 n plus a 12 into 5 upon 6 n minus a 12. So done. Your factorization is over. This is the answer. 5 upon 6 n plus 12 times 5 upon 6 n minus 12. Let us try one more. Second one. Second one is this one. 4m square minus 2n minus k the whole square, right? Now, if you see this properly, carefully, this is nothing but the difference of two squares, okay? In fact, this 4m square, if you write it in this way, 2m the whole square, that will be better. And this you can write as 2n minus k the whole square, right? Now, this happens to be my a, this happens to be my b. So this is of the form a square minus b square, where a is 2n and b is 2n minus k. That's it. Okay. So when a square minus b square can be written as a plus b times a minus b. Same way, if you substitute this a ka value and b ka value with 2m and 2n minus a, this can be written as 2m, that is a, plus this thing, that is 2n minus k. This is a plus b times a minus b, that is 2m, which is your a, minus 2n minus k, that's your b. Now don't stop here because you will have to remove this bracket as well. So it will be 2m plus 2n minus a k times 2m minus 2n plus k. Now this can be your answer. Okay. So your answer ultimately will be 2m plus 2n minus k times 2m minus 2n plus k. So this is the final answer for your factorization. Next one, the third one is take this one, x raised to 4 minus a b raised to 4. Fine. This can be written as x square the whole square. X raised to 4 can be written as x square the whole square minus b square the whole square. Fine. Now this happens to be of the form. Now if you take this x square as your say m, and this b square if you take as n, don't you think this is as good as m square minus n square, where m is equal to x square and n is equal to b square? Okay, so if m square minus n square you want to factorize, it will be m plus n times m minus n. Okay, so all you have to do is in this, you have to just put in the values properly. So this is of the form m square minus n square, where m is this x square and n is b square. So factorization will be m plus n, that is x square plus b square times x square minus a b square. But don't stop here, because here you can factorize it one more time. So x square plus b square, you cannot do much about it, but this can be again written as x plus b into x minus b in the same logic, in the same way. Okay. So ultimately this will be a factorized form. So it will be x square plus b square times x plus b times x minus b. That was question number 3. Question number 4 can be taken as this 6 minus 24 a square. Now this 6 can be written as root 6 the whole square, minus 24 can be written as root 24 the whole square, and this a square, right? I've just arranged it. Okay, so now this can be written as root 6 the whole square minus this square, I'll put it in one bracket. So this will be root 24 times a the whole square. So now this is of the form m square minus n square, where m is equal to root 6 and n is equal to root 24 times a, right? So m square minus n square can be written as m plus n into m minus n. So I will write root 6, that is m, plus n will be root 24 times a into root 6 minus root 24 times a. Now this is the factored form, or this is the factorization. The answer has to be like this. Okay, root 6 plus root 24a into root 6 minus root 24a. That was the uh, question which you have to deal in that way. Okay, or there is another way of doing this same question. Okay, 6 minus 24a square, right? This can be done in a different way. What you do is remove this 6 common out of it. So 6 into 1 minus 4a square. This can be written as 6 times 1 minus 2a the whole square. Now 1 and 1 square is 1 and the same. So this can be written as 6 into, now this is a square minus b square. So this can be written as 1 plus 2a into 1 minus 2a. Okay, so that should be your answer. 6 into 1 plus 2a into 1 minus 2a. So this answer is also correct. This is also not wrong. Okay, that was question number 4. Coming to question number 5. Question number 5 is uh, let me take this one. It's 144 a raised to 4 minus a b raised to 4. Okay, so let us see how we can handle this. Now this 144 I can write as 12 square, and this a raised to 4 I can write as a square the whole square. Fine. Minus this b raised to 4, can I write as b square the whole square? Of course I can write that way. Now this square, and this square, I'm going to take over this bracket. Which one? This square and this square I'm going to take over here. So inside I can write 12a square. Okay. Minus b square the whole square. Now what happens? This is my x, this is my y, and this is of the form x square minus y square, which I can write as x plus y times x minus y. So all I have to do is x and y values you have to substitute. So x is 12a square plus a b square times 12a square minus a b square. Now this can be further uh, you know factorized, because this is also a square minus b square. But even if you leave the problem here itself, no harm. Okay, it's correct. Or you can do this 12a square plus b square into, this can be written as root 12a plus b into root 12a minus a b. Okay, so if you add this one more step, then also no problem. Otherwise, if you end your question here, then also no problem. So that was all about this factorization chapter for the 7th grade. And I don't think I have much to do in this factorization, because for 7th grade, if you understand only this much, that is up to the grouping method and the difference of square method. Okay, now as you grow and as you come in the higher standards, that is the 8th standard and 9th standard, you will be learning factorization at a different level, where you will be factorizing quadratic expressions using the laws and using the different various methods. Okay, how to factorize. There also you will be using the basic methods only, but this will be the base of your factorization always. That's the end of this session. Goodbye, take care all of you, see you next time.